intro into retrieval augmented generation, but I'll talk about how this is being done. And also at BNY, so like Prasad sir mentioned, we also work with like agentic frameworks, and we create agents to do like different tasks to solve different use cases across the bank. So I'll just talk about how we use agents, and just to ask a question to all of you, since you had the session already, what is retrieval augmented generation? Can anyone like just briefly describe what it is? Okay. So suppose you ask ChatGPT a question and you want ChatGPT to answer a question based on a specific document. You upload the document and then you enter your query, right? So what exactly do you think is happening there? So your query gets embedded using an embedding model. Similarly, your document is indexed and the document is also embedded using an embedding model, the same embedding model. And then the similarity between the query and the document chunks are computed and the most relevant chunks are returned as a response. So that happens in the retrieval phase. And using those most relevant chunks and the query, the LLM generates an answer. So there are two phases in retrieval augmented generation. The first part is the retrieval phase, where it retrieves the most relevant chunks from the document. And the second part is the generative AI phase, where you're asking the LLM to generate an answer based on the retrieved chunks. So this is a naive retrieval augmented generation approach. So if you want to enhance this retrieval augmented generation, how can you do that? So in that case, either you can improve the retrieval phase by making like the retrieval embedding model generate better embeddings. So that's something that you can do by fine-tuning the embedding model, or you can add more layers to your retrieval phase. So once you retrieve the top relevant chunks, you can add like a re-ranker that would re-rank your chunks based on some additional context. So that's how you improve the retrieval phase. Or if you want like the LLM itself to be improved, there are other ways where you can fine-tune the LLM itself. But that's something that people generally don't do when it comes to RAG. So any questions here? Okay. Yeah.
Sorry, this is like a lack of knowledge about it. I'm just wondering, like the additional context provided by a re-ranker, for example, does that require additional input, or is that like embedded into the RAG process already?
So so it depends on you. So if you just want to re-rank based on the same query again, you can do that. Or if you feel like there is some additional context that you can provide in the form of documents or something else, then that can also be used. So a re-ranker is basically generally a cross-encoder that would help like embed your query and your document separately. When we talk about retrieval, it's mostly a bi-encoder that is doing the retrieval. So bi-encoders are like lightweight and cross-encoders are like heavy. So generally, it's just used in the re-ranking phase and not in the retrieval.
Okay, thank you so much.
So just to clarify, so D1, D2, D3, DK, that's all chunks of the original document?
Yes.
Okay, got it.
Okay. Now I'll just talk about like a hackathon that I participated in a few months back. Actually, Professor Ganesh had suggested that, had forwarded that to me, and I found it very interesting. It was by International Conference for AI in Finance. So they came up with this hackathon where it was basically on financial domain data sets. So we had to retrieve the most relevant financial documents for a set of financial queries that we have. So in order to do that, like they gave us like different kinds of finance documents, like quarterly reports and also balance sheets. And some of them were like in tabular format, some of them were in text format. So we had to like deal with parsing all this data and retrieving the top 10 documents for each of the queries that we had. So in total, I think there were like 6,500 queries. So our output would consist of like 65,000 rows because 6,500 queries and the top 10 documents for each. And I'll just talk about briefly about the approach. I know how much time. Okay, just 2 minutes. So first we started off like by experimenting with BERT and FinBERT. So BERT, as you know, is like a very good transformer model that we can use for different NLP tasks. But it's like a very generalized transformer model that just works on like normal, like without context basically. So we tried using BERT, but BERT didn't struggle to answer questions with finance terminology. So we then switched to FinBERT. So FinBERT is like BERT, but trained on financial domain data. It's called FinBERT and embedding. So we used that particular model, but that performed better than BERT, but it was resource intensive, and due to that, like we were not able to solve it on all the queries and documents that we wanted. The second thing that we explored was sentence transformer models. Since BERT and FinBERT turned out to be computationally intensive, we were not able to scale that. And we thought we can use like a lighter model to solve this issue. And because of that, we moved to sentence transformer. So we tried different sentence transformer models like paraphrase. We also tried all-mini LM and Distillo Robert. So these were the models that we tested out under sentence transformers. We noticed that since sentence transformers was not like that heavy model, we were able to generate the embeddings efficiently and also process all the queries and documents that we had. So this solution did show potential over BERT and FinBERT. And the next thing that we did was test with OpenAI's text embedding model. So we tested out text embedding ADA model. So even though we had like a premium subscription to OpenAI, we were still not able to run like all the queries and documents over it. It was still giving us like a token limit error. So that was a challenge that we faced with OpenAI text embedding. Now I'll just talk about the final solution that we use. So since we saw that sentence transformers were scalable, we took one of the best performing sentence transformer model that we use, paraphrase mini LM. So we used that to generate the embeddings, and we computed the similarity between them and got like the top 150 documents for every query that we have using FACE. So FACE is Facebook AI similarity search. So what that does is it helps us compute the similarity like faster than the normal cosine similarity between the embeddings. So once we got the top 150 documents, we re-ranked them again based using cosine similarity to get the top 10 most relevant documents, and this turned out to be like the most optimal solution for us. So yeah, I know it was like a bit much in like a short time, but if you guys have any other questions, feel free to reach out to me. And also yeah.
So did you mostly experiment with the embedding models? Did you not also experiment with chunking?
So
because that can affect your performance as well, right?
So we didn't experiment much with chunking. We mostly experimented with embedding models because we realized that like to get the relevant chunks, like embedding is like the most important part. So we tried playing around with like different embedding models, but like from the chunking perspective also, we did experiment with NVIDIA's re-ranker. So where we just upload the top chunks and the query, and it would again re-rank the final results based on that. But that didn't really help because the first shot itself, it was retrieving the correct chunks. So, yeah. Any other questions?
Any other questions for Sherine?
Did you try any other strategy other than cosine similarity, or was cosine the best, or is it the optimal one to use for re-ranking?
So basically, since we're generating the embeddings and then we compute the cosine similarity from using that, it doesn't actually mean like a distance I mean, it is a distance-based similarity, but it's a distance between the embedding. So it actually gives us the semantic similarity itself. So that was like a good, but then we also use face. So face is like another approach. That face is something that we added to make this computation like faster.
Thank you.
I don't have a question. I'm a colleague at Bank of New York, so I'll reach out later.
Oh yeah, sure.
I have other questions related to work.
Okay. Yeah.
Yeah, Sherine has a wealth of knowledge. I think you're here for a little bit, right?
Yeah.
So any of the financial projects, if you want to pick her brain at 4 o'clock, that's good. And if you're joining for dinner, that would be great as well.